For this problem, let's again highlight the important information that they give us here. First, we've got a volume of 300 liters at 150 degrees Celsius. And that's heated up until the volume is 600 liters. Now they ask us, what is the new temperature of the gas if the pressure remains constant? Now it says that the pressure remains constant, but what that really means is we can cross out the pressure because it doesn't change, therefore it doesn't affect our problem. So again, let's put together the pairs of variables we have up here in the problem. It says a gas with a volume of 300 liters at 150 degrees Celsius. Again, since it says at in between, we can bracket those together. And let's go ahead and assign variables to those two numbers. 300 liters, that's a volume. We're just going to go ahead and call that V1. And 150 degrees Celsius, we'll call that T1. And then it says heated up until the volume is 600 liters. So that must be V2. And that means that the temperature we're looking for, we might as well put a bracket around those, that must be T2. So let's go ahead and assign all our variables to the numbers over on the side here. So V1 is 300 liters, T1 is 150 degrees Celsius, and V2 is 600 liters. And we're looking for T2, so that's a question mark. Now what unit do we always put our temperatures in? Oh yes, that's right, we always put it in Kelvin. So we've got a little work to do before we can start here because T1 is not in Kelvin. So what we have to do to Celsius is we have to add 273 to that. When we do that, we get 423 kelvins. So that's our new T1. Now I'm going to show you a little trick here. Since we look in our problem and we can see that pressure remains constant, we're going to use the combined gas law, which is P1 V1 over T1. That equals P2 V2 over T2. Now you can get all your formulas just from this combined gas law, and I'm going to show you how right now. Since pressure is constant, we can cross it out. So what you can do is you can put an X through each P. So those don't really play a part. And what we're left with is V1 over T1 equals V2 over T2, which is Charles' law. So what we're going to do now is, since we're looking for T2, uh-oh, that one's on the bottom. So what we're going to do is, since they're equal to each other, what we can do is flip them over. So this ends up being T1 over V1 equals T2 over V2. It just makes it easier to solve the problem if the variable we're looking for is on top. So now let's plug in our numbers. T1 is 423 Kelvin over V1, which is 300 liters. That is equal to T2, and then V2 is 600 liters. Now how do I solve for T2? Both sides get multiplied by 600 liters, so extend your fraction lines out and put 600 liters on top on both sides. On the right it cancels out, and liters cancels out on the left. Now 600 divided by 300 is 2, and 2 times 423 is 846 Kelvin. That's our T2. And we're done.